Now that we understand how to write a general solution to a differential equation, we're going to include the initial conditions so that we can find the particular solution. So when we find the antiderivative of a function, we're finding a general solution. So for instance, if I'm integrating 2x cubed minus 2x dx, then I would use that power rule and say that's going to be, keep the 2 out of it, and then x to the 4th over 4, and then keep the 2 out of it, and then x squared over 2, and then plus c. So my function is x to the 4th over 2 minus x squared plus c. Now, the plus c is what makes this a general solution. And in the graph to the right, I have graphed a lot of different, essentially the family of functions, and I just used c as -5 through +5. But let's say I had these graphs, but I also knew that f of 2 was equal to 1. So that means that this point of 2, 1 falls on the graph. So that's going to help me determine the actual equation where c is not going to be c, but it's going to be an actual value. So let's take a look. If I have f of 2 equals 1, that's the ordered pair 2, 1. So I'm going to plug in 1 for y and 2 for x, and I'm going to leave it plus c, and essentially I'm just going to solve for c. So 2 to the 4th is 16. 16 over 2 is 8. 2 squared is 4. So that gives me 1 equals 4 plus c. Subtract 4 from each side, I get -3 equals c. So what is the particular solution? The particular solution is y equals x to the 4th over 2 minus x squared minus 3. So I'm just replacing c with -3. So what does that graph look like? That's actually one of the graphs here in black. So it's going through at -3, and here it is continuing up, going through that point 2, 1. Before we go any further, let's take a minute to just do one more practice for particular solutions to make sure we know what we're doing. So to begin, let's take a look at f prime of x is equal to 1 divided by x squared for the domain x is greater than 0. So I'm going to go ahead and rewrite that. F prime of x is equal to 1. I'm going to leave a little bit of room since I'm going to integrate. Is equal to 1 divided by x squared. And I'm going to integrate each side of this with respect to x. Now the left-hand side's pretty easy because, of course, this is just f of x. If you take the derivative and the integral, those are opposites. I don't need to add a plus c because I'm going to add the plus c to the right side. So on the right side, I have 1 divided by x squared. Well, remember, that's the same as x to the -2. So if you want to take that step so that you don't accidentally add 1 to each side, or add 1 and then divide by 3 and make that mistake, that's probably a good idea. So on the right hand side, now that I'm going to integrate, remember I'm going to add 1 to -2, not +2. That gives me x to the -1, and then I divide also by -1, and then I add plus c. Now cleaning that up a little bit, I get f of x is equal to -1 divided by x plus c, which is my general solution. Now I'm going to find the particular solution. Particular solution meaning I'm going to find a value of c using the fact that f of 1 is equal to 0, which means a point on this curve is 1, 0. The x value is 1, the y value is 0. So I'm going to take this equation, and instead of f of x, I'm replacing it with 0, because again, this is x, this is f of x. So I'm replacing that with 0, then I have -1, and instead of x in the denominator, I'm going to replace it with 1, and then plus c. And then I'm just going to simplify. So negative 1 divided by 1 is negative 1. Add 1 to each side. 1 is equal to c. So my final solution is f of x is equal to negative 1 divided by x plus c, which is 1. So that is the particular solution. Let's revisit the position function. When we learned how to differentiate, we looked at the position function, the velocity function, the acceleration function, and how they all fit together. So now what I want to do is look at that again, but now we're kind of going in reverse because we're doing the antiderivative. So just as a reminder, in case we've forgotten, the position function with respect to time is 1/2 g t squared, where g is the gravitational constant, plus the initial velocity times t plus the initial height, starting height of 0. At time 0. So if I just needed to find the position function, given this information, I could, because they have given me, obviously we're dealing with feet per second, so we're going to use g as negative 32. So I'm going to have 1/2 times negative 32 t squared. And then v sub 0, that's the initial velocity, so that's 64. And the initial height is 80. And so really I would just call this negative 16 t squared, because 1/2 times negative 32 is negative 16. So here is my solution, because I know what the position function is. But I can also do this using calculus. So let's think about the fact that, remember that s of t is position, and then s prime of t was velocity, and s double prime of t was acceleration. So what I can say is s double prime of t is negative 32, because that's the acceleration due to gravity on Earth. What if I wanted to find s prime of t? Well, doesn't that mean I could just integrate s double prime of t? So I'm going to integrate negative 32 dt. Well, if I integrate negative 32, that would give me negative 32t plus c. But that doesn't really help me much, does it? But what I do know is that at time 0, the velocity, which is s prime of t, is 64 feet per second. So at time 0, which is t, so negative 32 times 0 plus c, the velocity is 64 feet per second. So this gives me that 64 is equal to c. So that gives me that this function is negative 32t plus 64. So now let's go to the next step. If I want to find s of t, which is the position function, then I'm going to integrate s prime of t, which is negative 32t plus 64 dt. And if I integrate that, that gives me negative 32 t squared over 2, so that's negative 16 t squared, and then plus 64t plus c. And now the position, I have that at time 0, the position, the starting height is 80 feet. So I'm going to say that 80 is equal to negative 16t squared plus 64t plus c. And then, I'm going to replace t with 0, which gives me that 80 is equal to c. So what's my position function? S of t is equal to negative 16t squared plus 64t plus c, which is 80. So notice I did get the exact same solution just by working in reverse from the negative 32. And then obviously the other part has everything to do with algebra, so hopefully we know how to finish that. When does the ball hit the ground? We would say 0 is equal, Let's take a negative 16 out of everything. So that's t squared minus 4, I'm sorry, yes, minus 4 minus 5. And then negative 16 t minus 5 t plus 1. And so t would be 5 and negative 1, but negative 1 doesn't make sense in terms of the question, and so it would be at 5 seconds. It would take 5 seconds for the ball to hit the ground. Up next, we're going to take a look at sigma notation and summation formulas.